Hello and welcome to day 22 of learning ML from chatgpt. So let's get started. So in yesterday's lesson we learned about PCA, TSNE and LDA. So the analogies for these were the simple rotating cloud where you rotate it, where you can see the most spread out amount of points, spread out view of the points. Okay, then the simple analogy for the TSNE is when you fold a piece of paper with a lot of data points on it, and then when you scrumple it up and then you try and flatten it, then it's a smaller piece of paper, and then you but you don't lose any of the relative distances between neighboring points. Okay, and then we finally have LDA, which the simple analogy is trying to draw a line that separates apples and oranges as far apart as possible in a scatter plot. Okay. So now, I think we're not carrying on with dimensionality reduction as we're starting the week 4 lessons. Okay, so day 22, model optimization and hyperparameter tuning. Okay, let's go. So please give me, how many days are there? Okay, we've got a few extra days. Please give me, I only have one. Day 22's lesson. Soon I'll do a series like recapping days 1 to 5, then 5 to 10, 15, 10 to 15, 15 to 20. Then, yeah. That'll be probably after day 30. So, model optimization and hyperparameter tuning. Concepts. Hyperparameter tuning. What is it? The process of finding the best configuration of hyperparameters, parameters that are set before training the model, to improve model performance. Key hyperparameters: learning rate, batch size, number of layers, neurons, dropout rates, etc. So the learning rate, for example, I think if we had a linear regression model, like the line, it would slowly change the gradient by a tiny bit, and that tiny bit is the learning rate. And you don't want the learning rate to be too high, otherwise you can get a lot of noise, and we saw a graph at the start when we had too low or too high of a learning rate, and it just caused, I think it was over or underfitting. So yeah, we don't want underfitting or overfitting. We want just the correct amount. Okay, so then batch size, this is the amount of data in a epoch, and number of layers, neurons. So for example, when we did in the eminence data set with the neural network, we had 10 input neurons because we had the digits 0 through 9. And we also had 10 output neurons. I can't remember actually if we had 10 input neurons. I'll have to check that. Dropout rates. So when we did dropout, it was, I think, we did it on day 6. So what we do is we can have a dropout rate of 50. So it randomly drops out 50% of the data. And this can improve the model because it can reduce the model's dependence on the noise, and yeah, it can just make the model learn more non-linear patterns in the data. So we did it in 50%, and our accuracy went up 10 percentage points. It was really good. Grid search. Definition: an exhaustive search where you define a list of hyperparameter values. As the model is trained with every possible combination of these. Pros: simple and easy to understand, can be computationally expensive and time consuming. So this is when we're just doing loads of different hyperparameters and seeing all the combinations that we can do. So we could have batch size of 16, 32, 64, and then it's loads of nested loops. And then we could do epochs of 100, 200, so on, learning rate of 0.002, and we can go from there, and we can see which ones are best. But as we can see, in the earlier lessons, especially with Google Colab, it takes a lot of time to even run one, let alone doing it how many times. It's you have for int I equals 0, I is less than j, I plus plus. No. And then we have so many of these inner loops, yeah. Okay, so then we have random search. Instead of trying every combination, random search picks random combinations of hyperparameters from the given ranges. Pros. Faster and more efficient than grid search, may not find the absolute best configuration, but can often get close. Okay, so now we're on to Bayesian optimization. Definition: a more advanced technique that builds a probabilistic model of the function mapping hyperparameters to performance. It intelligently explores the hyperparameter space trying to find the best values faster. More efficient and requires fewer model evaluations, more complex to implement. Okay, so grid search example scikit-learn. We'll just copy this into our Google Colab so that we can run it whilst waiting. Okay, so we're having a random forest classifier and the number of, so these are the things we're going to do, and param grid. Yeah, so it looks like Grid Search TV from scikit-learn has an inbuilt parameter called param grid. This is, so what we do is we do the 50 estimators with 10, 50, 10, 2, 50, 10, 5, 50, 10, 10. Then we do 50, 22, and 50, 25, 50, 20, 10. We carry on doing that. So that's why it's inefficient. So we're just training it on the model, which is random forest classifier, and then CV equals 5. I'm not sure what CV here is though. Okay, good old neural network, nice. Okay, so we're creating model optimizers, add in. So we're creating a sequential model, adding a dense layer, 12 input neurons. Input dimension is 8, activation is ReLU. If you remember ReLU, if it's negative, just spits out a 0, otherwise it just returns whatever number was given. And then finally we have sigmoid, which gives the sigmoid is used for binary classification, so it will give probability for 0, probability for 1. Okay, now we're compiling it binary cross entropy as we use a lot this time. Wait, so what sequential model? What Keras classifier? Okay. Model.compile metrics accuracy. Okay. So we can see we have 8 neurons and then we go to 1. As it's a binary, as I just said. So we're having a Keras classifier, build function, create model. So this is the fine-tuning of hyperparameters. So we have 100 epochs and batch size of 10. Okay, now we're also doing this. Is this random? Oh, I think this is. Random distributions. Yeah, okay, this is the random search. And the best hyperparameters are the best one. Okay, assignment, task, optimize a neural network using the hyperparameter tuning. Instructions, build a simple neural network or use a pre-existing one and apply either grid search or random search to tune its hyperparameters. Compare the results with the default settings to analyze how much performance improvement is achieved. Okay, I don't think I'll be able to do this on Google Colab as it takes like 2 minutes alone to just... Oh, what's wrong with this? Yeah, we don't have an external Y train. So I'll just assume train equals Y train with model dot what is it? We need the target. Do we have targets? I'm just going to ask it to fix the code. Okay, now let's see. It's one of the first times it's given incorrect code. Okay, let's see. No way, it just does this. Okay, we'll just go to 4.0. Okay, I'll try asking it again. Okay, there are a few incorrect. You need to load data separately. You sure you have valid? Okay. Okay, we're going to use the iris data. Okay, that's fine. Oh yeah, why was I trying to get it from the model? My bad. Okay. So a train test split, so 20% is the testing, 80% is the training. And this code should work now. Okay, now let's paste this back into the Google Colab and try run it. I'm also going to add the next snippet of code just beneath. So this one was the random search, which is much more computationally efficient, but it doesn't always find the optimal solution. Well, computationally more efficient if the array size is greater than 1. Okay. Oh, test accuracy 1.00. Wow. On the iris dataset as well. I can't remember what our accuracy was when we did before, but wow, 1.0 is pretty good. Max step 10, min samples 5, and estimate is 100. Okay. So we can keras.wrappers. Let's refer to, so please fix this code as it has the following errors. I wonder if I can access Gemini on it now. Okay. Yep. So if chatgpt, okay, there we go. What is it doing? Switch mode to full point. Try again. Oh gosh, it's not working. Oh, there we go. The error in your accounting happens because the might not be installed in your environment. Okay, let's just. Okay, so we're just resorting to the TensorFlow because it has the keras library inbuilt. Is Gemini inbuilt here? Oh, it is. Oh no, it's not. Okay, how do we close this? Right. I also tried out Google. No, it was Meta's OLAM model, which you can run locally on your machine. And that was pretty good. But it wasn't nearly as fast as chatgpt as it was running locally. It doesn't have like all the NVIDIA GPUs like OpenAI uses. I'm pretty sure they do. What? Okay, yeah, import. But where do we do pip install? Okay, pip install TensorFlow, yeah. Okay, so exclamation mark. Okay, it's already satisfied. It's saying. Now let's try running this again. No, we still get no. Okay, I'm just going to tell ChatGPT I still get an error from this. I still get an error from this. Okay. So just to recap what it does, it creates our model of 12 input neurons, relativation, binary classification, and we're going through these and we're finding a random one. Okay, maybe we use just what if we just do this for random CV search. Okay, it seems like it's still what is ChatGPT doing? Okay. Okay, I think. Oh, here we go. Has it just cleared its? I don't know. Please make a different example of random. How is it called? Oh, what's it called? Random search. Oh, so we want ChatGPT to use a different example so that it actually runs. Example using similar model to. Okay, then let's just copy paste the code above. Oh, and ChatGPT just crashed. Oh, okay. Well, I think that's all for today's lesson then. If ChatGPT's not here. So, yeah, thank you for watching. And just to recap, we learned about like changing the batch sizes in order to like improve our model's performance. So we can either do it like brute force, doing every, or we can do a random one. And there's also the one where it learns. I can't remember the name of that right now, but it learns the best one by just exploring it. Yeah, so thank you for watching, and I'll see you in the next video. Goodbye.